Which of these molecules are polar? So we have SO3, OF2, BeCl2, CCl4, and O3. So first, I'm going to show you how to draw the Lewis structure for OF2. So our central atom is going to be O, and then our outside atoms are going to be F. And we're going to find out, well, how many valence electrons are in each element. So oxygen has 6, and then fluorine has 7. And we're going to add all those together to find out how many electrons go in the molecule. So that'll be 20. So 4 of the electrons are already being taken up by bonding between the F's and the O. So 20 minus 4 equals 16. And those are the electrons that we are going to put around the molecule. So all we do is we just start with the outside molecule, the outside atoms, and that's balanced, and that's how it is. So now that we have the Lewis structures for all of them, we're going to start with SO3. So SO3 has resonance structures, and we're going to find the partial charges of SO3. So oxygen is more electronegative than S is. So all of these are going to be more electronegative, and then this one's going to be more electropositive. So now the bond dipoles are going to go from the more positive to the more negative. So how this is going to work is we're going to draw the molecular geometry. So the molecular geometry for SO3 is trigonal planar. So the way that it's going to be drawn is something sort of like this. So since there's no non-bonding electrons on the central atom, all of these domains are the same. And when all of the domains are the same, then that's going to be a nonpolar molecule. So SO3 is nonpolar. All right, next we have F2. So we have the Lewis structure, and we know that F is more electronegative than O is, so we'll put that there. So, like I said, it's going from the positive to the negative. So the molecular geometry of OF2 it's going to be bent because we have these non-bonding electrons. So it's going to look something like this with the non-bonding electrons on the central atom, which is causing it to bend. So now we draw the dipoles and we add them, and since they don't cancel each other out, that means that this molecule is polar. So OF2 is a polar molecule. Now for BeCl2, we have the Lewis structure for that. We know that Cl is more electronegative than Be is. So that means that the bond dipoles are going to be going towards the Cl atom. So now we're going to draw the molecular geometry, and this is just going to be linear because there are no non-bonding electrons on the central atom. And since this is linear, both of the dipoles cancel because both of the domains are the same, so this is going to be a non-polar molecule. So for CCl4, we have Cl, which is going to be the more electronegative, and then your central atom is going to be more positive. So that means that all the dipoles are going out towards the Cl atoms. So to draw the molecular geometry, this is going to be a tetrahedral. So it really just looks like this. So since all the domains are the same, that means that this molecule is going to be nonpolar. Okay, and now for O3, these are two resonance structures for O3. So since this molecular geometry, it's bent because there's a pair of non-bonding electrons on the central atom, which means that the top atom is going to be less electronegative than the bottom atom. So that means that the dipoles are going to go towards the bottom O's. So that means that there is going to be a net molecular dipole because they don't cancel out when you add them together. So then O3 is a polar molecule.